for me, my AI journey back in 1987 was with this thing called Lisp. I don't know if
God,
you remember that.
God,
Lisp
yes.
processing. So and it was severely limited. I mean, if you look at, and I emphasize that for you're laughing because you know what I'm talking about. It was painfully limited, painfully limited. Were you folks back then looking at machine learning? And if so, how did you do it with the compute power that we had?
So this is why I talk about unanticipated phone calls and unanticipated conversations. So a little bit of history with that, and we'll go back to the conversation. So what most people don't realize is the stuff we're dealing with today was really turned into the modern era in 1950 by Alan Turing, right? They have the movie
Yeah.
about him, right? And the
Yep.
movie's actually named after his paper that's all about AI,
Yeah, he
right?
actually got it to recognize a cat or something. I forget what it was.
There was a few things like that. And then the term came around about 5 years later by during a conference hosted by Dartmouth when they started using the term AI. List was invented, all these other things. There was approximately a 20-year period that is often referred to as the AI winter, where like everything went sideways. About the time I was just starting at NSA, we were coming out of that ice age, the AI ice age. And the agency, interestingly enough, DARPA funded the first set of Alan Turing's projects, right? So created a lot of things we're using today. When the winter started to thaw, they came back and said, "What can we do?" And we have this use case. And you seem to be interested in this, and the only one interested. Why don't you run the project? And I was like, "Okay, cool." But what had happened is, and this is really interesting because to your point, the data wasn't available, the cost to store the data wasn't there, the compute power wasn't there, but the algorithms were.
Yeah, the
Interesting.
math was there.
The math was there. And the algorithms we're using today to solve this problem are the same ones we used decades ago, but the NVIDIA chips actually compute differently. It's not that they have more horsepower, it's not brute force. They compute differently. The cost of data has gone, the cost to store data, and we no longer need to worry about transferring between machines. At the time, we had separate banks of storing this data that we were working with. We had these Ethernet cables, which were 1/10 of the power they are today, that we would have to transfer these data sets back and forth. We didn't have as much RAM. Now you could do all that stuff on one board. So between the cost of the data, the availability of the data, different computing, and doing these transfers at machine speeds instead of electrical speeds across the room, we have made major advances. Have we figured it all out yet? No, but we will.
No.
But we will.